All right, class. Hello. Um, for me, it has been a little while since I have made a video because I am just getting back from April break. So, as I am making this video, I am getting back from break, and tomorrow we are back to school. Um, Hopefully, it's a little early in the year as you're watching this, and we are a little bit ahead of schedule. And not any later than that. But today, our goal basically is to add and subtract polynomials. You have done a little bit of that, hopefully. Multiply polynomials. This is our main goal. Multiply bigger polynomials, and make sure we know when to combine like terms when we're doing that. So make sure that everything that we do is completely simplified, which is obvious, because that's what we do in math, right? We simplify. So today, because I'm just getting back from break, I figured I would share with you, and maybe this is outdated information, maybe this is current, but it's time for. This is the segment. It's going to be called A Day in the Life. It's time for A Day in the Life. So I just got back from a cruise to Bermuda. Just wanted to share a little bit about that. If you're a dirt bike or a jet ski or a motorcycle or something like that type of person, I would love to talk to you. Please strike up a conversation because I just rode my first jet ski when I was in Bermuda and drove a motorcycle. So I had to get into the leaning and how jet skis handle at top speeds. I have a little bit of a story to share, so feel free to ask me about that. But it was my first cruise. It was a lot of fun. I feel recharged and ready to get back to work. As I'm making this video. So tomorrow we are back in school, for me at least. So that's where I have been at, and hopefully you just had a restful vacation or have a restful vacation coming up, etc., etc. But today we have to cover the FOIL method. So some of you might have heard of it. It's called the FOIL method, F-O-I-L. And that's just a way of how you're going to distribute, I guess. Distribute twice, though, in this case. So we're going to call this a double distributive. That's something I want you to kind of be aware of. Maybe underline that on your paper. Please underline that kind of clearly. A double distributive property. So we're going to multiply two binomials. That means bicycle is 2, binomial is 2 things. So just so you have an idea of what two binomials look like, that'd be like x plus 2 times x plus 5. That's two binomials. The first one is a binomial because there's 2 things there, x plus 2. And then the second one is a binomial because there's 2 things there, 2 terms, x plus 5. So FOIL just tells you how to do it, okay? FOIL stands for the following. First. So let me show you what I mean. I'm going to keep this kind of color-coded. Maybe I'll bring this example down here for you. Okay. So just write what I am writing. If I write it, you write it. First times the first. So you distribute this. And then you're going to do something called outer, which is meaning that you're going to distribute this here. So this is outer. Whoops. You don't really need to use the term FOIL, but what we're going to be doing is we're going to be multiplying. We're going to be distributing this x to both of these. So x times x is this green loop. That's the first thing times the first thing. And x times x is x squared. Outer is going to be this blue loop, ribbon I call it. That's x is being distributed to 5. So you need to distribute the x to both things. You need to distribute the 2 to both things. So 5 times x is 5x. Inner. Let's talk about inner. That's what this is. So now we're going to take the 2 and multiply it by the x. Those are the 2 inner terms. So that's 2x. And lastly is last, of course. And that will be in red, I guess, because I'm running out of colors here. So last term times the last term. That's the 2 times the 5, which is 10. And that's all you're doing. So think about it as it's a double distributive. Okay, so think about that in this case. What you're doing is you're distributing first, you're distributing the blue and the green. That's the first distributive, right? And then the second distributive is when you're taking the red and the purple. So you're distributing this guy, and then you're distributing this guy. So distribute this both places, then distribute this both places. So double distributive. And that just, knowing that it's, I don't know what this is saying. What we need tells us, I think this is supposed to say to do. FOIL tells us what we need to do, basically. Oh, I think it's right here. FOIL simply tells us what we need to multiply. So FOIL is just a way to remember how to do it. If you like FOIL, you can use it, but I like to just think of it as a double distributive. So let's go with these same colors as we have up here. So first times the first. So here's another example. X times x. Well, that's x squared. Then we have the outers right here. So x times 7. Well, that's 7x. And then we have the inner, which is in purple. So that's 1 times x. So that's 1x. And then we have the last, which is red right here, and that's going to be 1 times 7, which is just positive 7. So that's where we're left. But here's the thing about this. You notice that these are similar terms. 1x and 7x becomes 8x. So here's a situation where you are going to simplify. You are going to simplify just those middle terms. Anything that's the same variable and the same, think about that, what have I always said? Same variable, same exponent, okay? These are not going to combine because they are different exponents, but if they're the same variable and the same exponent, then you can combine together. This is our final answer. Okay, so that's what FOIL is. We're going to do a couple more examples and then some now you tries. So I'll go through these a little faster. Just give me 1 second. I'm going to put some slippers on because the floor of my house is pretty cold, and I don't like that. I'll be right back. All right, so I instantly now have my slippers and a glass of water, and that is good. So, if you don't have a pair of warm slippers for the, winter time, the spring, the fall, I would recommend you get some. It's going to change your life, honestly. It took me years to learn that. I'm trying to teach you from a young age. Get some slippers, okay? All right, here we go. Some examples. I might try a 2-variable example with you, so let me just kind of not forget about that. X plus 2y, x minus 3y. So we'll do that in a second. But for now, let's focus on this. So I'm going to kind of go a little faster. I'm just going to go like this. X times x is x squared. That's the first ribbon here. Watch what my pen does. X times negative 2 is negative 2x. Now we move through the green. Let's do both of these. So 8 times x is 8x. And now 8 times negative 2 is negative 16. So hopefully you see what I'm doing, and I'm simply going to combine the middles. Well, negative 2 and positive 8, they're the same variable, same exponent. This is positive 6x. Can't change the negative 16, bring it down. Can't change the x squared, bring it down. This is my final answer. So this here is your final answer. Let's look at the next one. Let's do the same thing. We'll do red and green. We'll keep it Christmas themed today. Okay, so hopefully you see what I'm doing. I'm going a little faster. You can always go back and I kind of explain step by step what I'm doing. But I try to go a little quicker so you can just see a little bit. You can always pause it and try what I'm doing. Now let's see what we got. We got these guys. That's negative 5x when we combine them. Can't do anything with the 6. Can't do anything with the x squared. Can't simplify those at all because they don't have anything with the same variable and the same exponent. So that's your answer. Look at 3. I would encourage you to try pausing the video before you do it. Before I do it, rather, because I'm going to do 3, but I would like you to try to pause the video and see if you can get it if you have a second. So go ahead and pause it, or just play right through if you're not sure. Okay, so here's what I'm going to do. 2x times x. Well, 2x times x is still 2x squared. It's just the only thing different about this really is that there's a 2x here. 2x times 3 is 6x. We kind of know all of this stuff. It's not really new. 1 times x is just 1x. 1 times 3 is 3. So there's that. We look to what is similar terms. Now, in this case, we don't really have to think about it. It always ends up being these middle terms, but we do want to be aware that it's anything with the same variable and same exponent because it won't always be so easy as it is right now. It will get a little tougher. It's going to progress. Okay, and there's our answer. Think about what you might even do for this one. Take a second and think about what you might even do for this one. I'm going to show you what you have to do. and maybe pause the video and try that. Okay, so for this one, x times x is x squared. X times negative 3y. That's a weird one, but that's actually going to be negative 3xy. You just kind of clump them together. X times y is xy. X times z is xz. Z times t is tz. You just kind of clump it together. And we'll talk more about that. I just want you to get the basics here. 2y times x. Well, that's going to be positive 2. You can put it as yx or xy, but it's usually typical to put it alphabetical. And now this last one is going to be negative 6y squared. We still have similar terms, only these guys are similar, so that's negative 1xy. The x squared can't change. The negative 6y squared can't change, but only those middle terms can be combined. So that's our final answer there. So take a moment, pause the video, try the two now you tries, okay? Neither of them are as tough as that one with the two variables, but they're, they take a little bit of work. So think about it, pause the video, and see what you can do. All right, hopefully that went well for you. Just to break things up, a nice little meme here. Sometimes they're punny, sometimes they're not. This one is, I would say this one's punny. Well, this one's not really a pun, is it? Looks like someone threw caution to the wind. I did like that one, because you got the caution tape thrown into this tree. It looks like the wind must have caught the caution tape, so it looks like someone has thrown caution into the wind. Hope you enjoyed that little break. And now we're back to page 2. So flip that paper over. Multiplying polynomials. So a monomial is like a term. Okay. A monomial is just one term. So an example of a monomial, we've talked about this a little bit, is 8 is a monomial. Okay. X to the third is a monomial. It's just one thing. 3x squared y is a monomial. Negative 2z is a monomial. Because it's not two things added or subtracted together, okay? So you got to understand that this is a monomial, this is a monomial, this is a monomial, this is a monomial. It's just like one clump. But when you take a bunch of those and put them together, you get a polynomial. Polynomial. If you think about it, we talked about this, I think, before. The monorail at Disney has only one rail. Monopoly is when one person is in charge. A monocle is one eyeglass. Polygamy is when you have more than one wife, believe it or not. Polytheism is when you believe in more than one god. What else can we say? I don't know. Polynesian, I believe, is many islands. I could be wrong, but I think that's what it means. So polynomial is many monomials. So if you even just took these things and added them all together, literally what we have up top, and you said 8, if you just combine them together, a couple of these different terms, that's a polynomial. Okay. If you took the next one, 3x squared y minus 2z, and combine it together, that's a polynomial. So anytime you have two or more combined together, so like let's say our last example, 5x plus 3y to the third minus 2z plus 8. That's a polynomial, okay? With 4 terms. 1, 2, 3, 4 links on the chain, if you think about it that way. So today we multiply polynomials, and we can multiply them using the distributive property, right? We know about how to do this. I think you can just quickly try this, okay? Pause the video, give it a shot, and I'll write the answer. Hopefully you came up with that. That's what you're supposed to come out with. But now we're going to do larger polynomials, okay? So hopefully you have enough space on your paper. You can always use the margin or attach another paper if you need to. We're going to multiply some larger polynomials. So this one, I don't have a lot of space to put my ribbons in, but let's just do this. Look, we're going to distribute this x to everything. 1, 2, 3, okay? We're going to do this by horizontal alignment. So everything's going to be flat like the horizon, okay? Left to right. Just look out in the horizon. Everything's going to be nice and flat. So x times x squared is x to the third. x times 3x is 3x squared. X times 4 is 4x. That's everything for that. Now we're going to do the other part, and we're going to keep it all on the same line. 1 times x squared, 1 times 3x, and 1 times 4. That's what we have. Now, horizontal alignment says we have to combine things that are the. What can we combine? Think about it. I say it a lot. Same variable and same exponent. So, does he have anything that's the same variable and same exponent? No. So x cubed is left alone, and we will kind of just scribble that out as we go through. We can put a nice thin line through it. Maybe it'll be a little smarter, but oh well. Okay, this guy, an x squared. Is there another x squared? Yes, there is. So those guys together, this is a 1. That's 4x squared. Don't change the exponent when you combine them. Just like when you have 3x and 4x here in the next line, you will not change the exponent. You'll just keep it regular old x. So 4x and 3x is 7x. And I like to just put a line through them. And the 4 has no friends, nobody to combine with. He's alone. So that's multiplying by horizontal alignment. It's a little bit more complicated, but it's the same exact thing we did with FOIL. Now let's look at a couple more. Let's try it by vertical alignment. I know I'm moving a little bit faster now, but I don't want the video to go on too long. So the last one, you should be able to figure this out. Same variable, right? Same variable and the same exponent, right? You can only combine things that have the same variable and the same exponent. So these ones are multiplied by horizontal. These are the now you tries, so don't forget to do these two. By horizontal or vertical, I'm going to show you vertical now. The last thing I'm going to show you. I am going to move a little quicker because you can solve anything by vertical or horizontal, technically. I just want to show you two options. So do the same thing, okay? 2x to the third, I'm going fast, minus 5x squared, plus 2x. Hopefully that made sense to you. And then I'm going to go like this. 1, 2, 3, right there. Don't forget this guy. And I'm going to line up anything that's the same. So this is going to be negative 10x squared. I'm going to put it here. It's going to kind of look like a step ladder when we do this. Negative 5 times negative 5 is positive 25x for the second ribbon, and then negative 10. And what happens is you end up getting things that are ready to combine already stacked. So everything's stacked nicely. This is negative 15. X squared stays x squared. This is 2x and 25x. That's 27x. And negative 10 has nobody. So that is how you do it by vertical alignment. So you just kind of stack them so that they're organized for you and it's a little bit easier. I'm going to end the video there. Do not forget to do the now you try, and I will talk to you soon.